Okay, this is for section 4. So we've been talking about sines and cosines. Now let's graph these guys. And if you've got your calculator, you can graph them at home. On your calculator, one of the things that you will want to make sure that you're doing, especially if you're in chemistry or physics, is you want your mode to be in radian. So that you can see, it's a little bit easier to graph them that way. And I set up for my calculator the x intervals to be pi over 4. You can actually type that into your calculator to set your intervals. And so on the graph, even on this graph, even though you see decimals, the intervals listed on the x-axis are pi over 4s. Okay? And so now let's graph one of these guys. If I graph sine of x, there it is right there. There's the sine of x. And notice that if we were to go through and identify, analyze, discuss, talk about, one of the things that we would see is that this graph has a range that goes from -1 to 1, and it has a domain that goes from -infinity to +infinity. There's no point on this graph of the sine curve where we will ever go past 1 or below -1, and there's no point on the sine curve where an x value will not work. Okay? Notice there's no asymptotes. There's no asymptotes. There's no points of discontinuity. It is continuous. There's no vertical asymptotes. It is bounded above and bounded below. Okay, because of this range, it's bounded above and bounded below. And it's just a really interesting graph. This is what your base graph is going to look like for your sine curve. Okay. One of the other things you might notice too is that this guy has periods of falling and rising. Okay, so it decreases right here. It increases right here. It decreases right here. So these things happen on a regular basis, and we're going to say that our sine curve is periodic. And this just means that after you go so far, it starts to repeat itself. And if you'll look on the sine curve, if we start at 0 and we trace it out with the highlighter, once you go from 0 to pi, you start, or from 0 to 2 pi, you start to repeat. So that's kind of one of the things that happens when you're looking at a sine curve. Okay. Now, what about a cosine curve? Let's see if we can see this guy. Oh, there he is. And look, he's off just a little bit. He's the sine curve moved to the left. Pi over 2 units actually is what it is. Okay, so the cosine is the sine curve moved left by pi over 2 units. So these guys are very closely related. Everything we said about the sine is true for the cosine. Okay, and they're going to make some just really interesting graphs that we'll be able to examine and look at and discuss over the next few days. Okay, now when we talk about what's going on with your sine and cosine curves, one thing that we need to always be aware of is the amplitude. The amplitude. And the amplitude is basically half the height of whatever your wave looks like. Okay? And it's always going to be the absolute value of the number in front of the sine or the cosine. Amplitude is not negative. Please don't write down a negative number for your amplitude. Okay, you'll miss it every time. But look at your sine and cosine curves here. We got numbers in front of all of these cosine guys. Well, what numbers in front of y equals cosine x? 1. What numbers in front of 1/2 cosine x? 1/2. What number's in front of negative 3 cosine x? For amplitude, it will be 3. Okay? And so these are the amplitudes. These are how tall. These are half the height of your wave. And so what do I mean by that? Well, let's look at this first guy real quick. Notice that when I'm looking at this, the height of this wave, okay? The height of this wave goes from -1 to +1. Would you agree with that? Okay? Here's a +1 up here, here's -1 down here. So I travel 2 units for all of this to happen. The amplitude is half of that, and it's always positive. Okay? What about 1/2 cosine x? Now think about your functions. Think about all the other functions that we've ever worked with. If you had a half in the front, didn't that make your graph wider? Well, let's have a little look here at what happens when we do 1/2 cosine x. Okay? So now we've got what? A wider shrink. We've got that vertical shrink that's taking place on our graph. And if you'll notice, now we're going from a half down to a -1/2. So how far am I moving? I'm moving 1 unit. So we're going for half of that for our amplitude. Okay, so amplitude will always be positive. It will always be positive. All right, and then here's, I'll just let you look. There it is without the other graph on there. Okay. So this guy has a vertical shrink of 1/2, just like if we were looking at a regular function. Vertical shrink by a half. Okay. Okay, so let's get this guy off, and let's put this guy back on. And let's take this guy off. Let's take this guy off. He's not letting me. Let's do it now, though. Here we go. Okay, so let's look at this last guy then, cosine 3x. Now remember, the amplitude is just 3. The amplitude is half the height of the wave. So the wave, the height, has to be a positive distance. You don't drive -10 miles to go watch the Thunder play. Okay, you drive 10 miles from home and back to watch the Thunder play. So look at this guy. What happened here? Well, we've got a vertical stretch by what? 3. Okay. Notice that the height of this guy gets all the way up to 3 and all the way down to -3. So half of that height, there's 6 units right here. There's 6 units. So half of that is 3. It's not -3. Now, instead of opening up like we do with our original cosine, what's the other thing that's happening here? Okay, we're going to open down. We're going to, well, let's not say open down. That's bad. Let's say that we're going to reflect over the x-axis. Just like you've done on all the previous functions that we've looked at this point in time, you follow the exact same rules. Okay, a topic that goes right along with amplitude that you'll hear a lot about when you are doing sine and cosine curves is the period of a curve. And so the period of a sinusoid is 2 pi over b. And b is going to be this guy right in front of the x, the number in front of x. Okay? So 2 pi divided by b, whatever that might be. And graphically, the period is the length of one full, complete, beginning to end cycle of the wave. So on all of these guys, we've got a period. And there's a number in front of all of these guys that we look at. And again, it's the absolute value. The period cannot be positive or negative. If you write down a negative period, that's incorrect. So let's look at this first guy. The number in front of x is just 1. So the period is 2 pi over 1, or 2 pi. And so if we look at this graph for this guy, 2 pi. So in other words, if we started right here, by the time we go all the way up, all the way down, and get back to the middle, this point right here is going to be 2 pi. So how many periods of this graph do we see here? Well, we see 2 of them, because I want to go from negative 2 pi, complete one full period, and then I'll start a second one. Okay? So the period of your normal sine and cosine curve, well, the period of the normal sine and cosine curve is going to be 2 pi. All right? And we can see that here on this graph. And if you're graphing your stuff in radian mode on your calculator, you can see these things too. Okay? Well, what about the next guy? Again, we just want to look at period now. Can we tell the amplitude for all of these? Yes, the answer is yes, we can. The amplitude on this first guy is what? 1, because that's the maximum height and the maximum depth, or that's, you know, half the height of the wave is 1. So we can look at that. What about this guy? The period for this guy is what? 2 pi over, well, what number could this possibly be? Well, think of it this way. 2 sine of 1/3 x. So what number is that going to be? 1/3. And if you have a fraction, you multiply by the reciprocal. So that gives us 6 pi. Okay? Well, what do you think is going to happen? Think about all the functions that we've worked with at this point in time. Think about all those functions. And if you put a number larger than 1 inside the function, what'd it do? Stretched it out. Look at that. Here's our sine curve, and notice that we can't even see one whole period of the sine curve right now. It's just too big to fit on our screen. But here it starts right here, and it goes to the top, and then down to the bottom, and it's on its way back up to the top again. But we don't see it. It's not there. Also notice that it's reflected. This guy also, he reflects over x. Well, how do we know that? That negative sign. So just like in our regular everyday functions that we work with every day, cubic and quadratic, these guys are going to behave the same way. So on the first problem, we didn't have any stretching or shrinking at all. But on this guy, what's happening? We've got a horizontal stretch. Okay? By 6, by that 1/3 right there. Right there, that 1/3. Anytime you have a number less than 1, you're going to get a stretch on the inside. So here it is, stretch by 1/3. Okay? And compare those two guys right there. They're really interesting looking curves, okay? Well, let's get rid of these parts, and let's break this connection here. Let's see if I can do it. No, he doesn't like that. Let's add this third guy on here. What happens if we... Whoop. What's the period of this third guy? What's the period of this third guy? Well, the period for this third guy is going to be 2 pi over what? 2. Not negative 2, just plain old 2. In other words, the period for this guy is going to be plain old ordinary pi. So let's see here if I can... So let's compare these two. Now look what happened. I took that number in front of the x, I made it larger than 1, and all of a sudden it had a horizontal shrink, and you can see there's a lot more of this guy going on. What else has happened here? Okay, it's been reflected over the y-axis. Why? Because we've got a negative inside the function. Just like if we had a negative inside the function on some of our other problems. So this is what the period does when you're working with sine and cosine. And the period for these guys on a normal function is 2 pi. Okay, so we need to keep that in mind. And that's why we divide by the number in front of x to get the period for a particular function. Okay?